Alright, so this is the final video that I am going to record for the year. I'm just as excited as you guys. Okay, so, alright, so this is on radians and degrees. Okay, so if you took my class last year in geometry, you might recall that we had to change our calculators. So there's a mode that we had to change from radians to degrees to make sure that we calculate the side of a right triangle correctly. So if you look at this here, all these angles are in degrees, right? So that's why we had to change our calculator to degrees mode. Now, if any of you do take trigonometry, there will be times where an angle, instead this angle might be given as a radian measure. So radian measure might be something that has a pi in it, and you might have to convert that convert that into a degree measure in order to solve the problem. Yeah, so but anyway, I'm just going to discuss what a radian is. So if you want to go to that website, you can go to this website in the notes that I will post. You can go ahead and look at that website. It's kind of cool. But basically, the idea of a radian, it just comes from the idea of a radius. So you see this blue here? This is a radius of a circle. So radian, it basically takes this radius and kind of like traces it on the outer part of the circle. So this measure here is considered 1 radian. So the measure this angle here, and that's basically what is here. So it's basically the angle that is made when we take the radius and wrap it around the circle. So 1 radian here is approximately 57.2958 degrees. And that's what happens when we take the radius of a circle and wrap it along the perimeter. Okay. Now if we want to expand this idea further, so we know that 1 radian is like this. So what if we have 2 radians, 3 radians? If we go ahead and do halfway around the circle, this is that 3.14159 number. That is pi, if you guys remember what pi was. So pi is basically this here. So if you have pi radians, you're going 180 degrees around the circle. You're making a semicircle. Okay. So what this means is that if you go in a full circle, you're going 2 pi radians, because you're multiplying by 2 pi radians. You would go the entire 360 degrees around the entire circle. But the main idea behind this is we're going to use this idea that pi radians is 180 degrees, which is the conversion factor that you're going to need in order to convert a degree measure to radians and to convert from radians to degrees. So you're going to be using these certain conversion factors. Okay? So this one. So it says convert each degree measure into radians. Okay? Convert each degree measure into radians. So what I see is this is a degree measure. If this is a degree measure, when I convert to radians, we have to multiply this by the ratio of pi radians divided by 180 degrees. Okay? So what I see here is 45 goes nicely into 180. I believe this is just a 1 and this is a 4. So in order to convert this, this is 1 times pi, so that's pi divided by 4. So what this means is a 45 degree angle is the same thing as pi over 4 radians. Okay, this one, negative 200 degrees times pi over 180 degrees. So we're just converting these degree measures into something into radians. Okay, what I see here is there's a nice common, I think 20 I see, because 200 divided by 20 is going to be 10, and 180 divided by 20 is going to be 9. So in order to convert this into radians, it's just negative 10 pi over 9. That's it. Okay. For this one, So we have 170 degrees. 170 degrees, same thing. We need to multiply this by pi radians divided by 180 degrees. So what I see here is that they both share a common 10. This is 17, this is 18. So this is 17 pi over 18. Okay, this one, negative 120 degrees, multiplying that by pi over 180 degrees. Okay, so what I see here is that each of these numbers is divisible by 60. So since they're divisible by 60, 120 divided by 60 is going to be 2. 180 divided by 60 is 3. So this is going to, in order to convert this to radians, it's negative 2 pi over 3. Negative 2 pi over 3. Okay. Next one, convert each radian measure into degrees. So if we want to convert from radians to degrees, we're going to do the opposite. We're going to multiply by the ratio 180 divided by pi. We want to get rid of the pi in order to create degrees. Okay. So 5 pi divided by 4. And then we're multiplying that by 180 degrees divided by pi radians. If you look at this, the pi's will cancel each other out. I believe 4 goes into 180 nicely. This is 45. So we take 5 times 45 and then divide it by 1. So that's going to be 225 degrees. Okay, next one. So this one, convert this into degrees. So negative pi over 3. Multiply this by 180 degrees divided by pi. Pi's cancel out. So we're left with 180 divided by 3. Now 3 goes into it goes to 180 nicely. We're left with 60. So this is negative 60 degrees. Okay. This one, 2 pi over 3. We can multiply by the ratio of 180 degrees divided by pi. Now the pi is going to cancel. Now, same idea here. We have a 3's here. 3 goes into 180 nicely. 60. 2 times 60 is going to be 120 degrees. Last one. Negative 3 pi over 2 multiplied by 180 degrees divided by pi. The pi is going to cancel out. And then let's see, 2 goes into 180 nicely. So this is going to be 1. This is 90. So negative 3 times 90 is going to be negative 270 degrees. Okay. So that's basically how you would convert from degree to radians and how you convert from radians to degrees. Okay. So now that I just showed you that, I want to show you how this all connects. Okay. So in trigonometry, there might be times where you might have to find sine of pi over 3 as well as sine over 60. And how would you evaluate both of those expressions? So what we analyzed earlier, right? So all of these here, these are all radian measures. On the bottom here, these are all degree measures. So if you plug in, like let's say you want to find sine of pi over 4 or sine of negative 10 pi over 9, you would use radian mode. If you want to find sine of 225 degrees or sine of negative 60 degrees, you would use degree mode. So that's kind of the difference that I didn't really get to explain to you guys. So if we were all in class right now, I could show you how to do this using graphing calculator. But since we don't have access to graphing calculators, let's resort to Desmos. Okay, so if I resort to Desmos here, so if I were to just do this, okay, so what we have here is by default, Desmos should already be in radians. It's already in default by radians. So if I just type in here, sine of pi divided by 3, that's this. You see that there? That's this, 0.866. measure, and that's because that option is in radians. Okay, now let's see what happens if I change it to degrees. If I change this option to degrees, so I'm just going to just use this here, and then if I go all the way to the bottom and I change this here to degrees, and then let's see what happens if I type in the other prompt. Let's see if I type in sine of 60. Notice here, sine of 60, after changing it to degrees, is going to be 0.866. And notice that these two values here are the same. Now, why might that be the case? So let's think about this here. So pi over 3 here, this is our radian measure. So if we wanted to convert this to degrees, then it becomes 60 degrees. As you see here, pi over 3 in radians is the same thing as 60 degrees. This is why that if your calculator is set to radian mode, you're going to get the same output as if the calculator was in degree mode. So because this calculator knows you're typing 60 degrees and pi over 3 radians, which represent the same thing. Okay, so, and that's why I just wanted to show you that. So you can try all these other values that I have here. You can try cosine and tangent. See, pi over 4 should be the same thing as 45 degrees. Pi over 6 should be the same thing as 30 degrees. If you try this out in decimals, you're going to realize that these two have to be in radians, and these two must be in degrees in order for these to be equal to each other and these to be equal to each other. Okay, all right, hopefully that wasn't too confusing. Let me know if you have any questions, and that is the last video that I am going to record for you guys. Woohoo! Time for summer. Okay, bye.